All right, hello everyone. Why don't we get started today? Thank you for attending the webinar and for spending 30 minutes of your day with you. We certainly appreciate it. Please enter any questions or comments that you have, or if there's any issues with the audio or video, enter them in the chat and we'll be monitoring that. We may or may not, depending on how things go, have time for questions at the end, but we will certainly get back to you directly via email within a day if we don't have time. So please enter your questions. So today we're going to be talking about IT Leader's Guide to DevOps Quality. First, a little bit about me. I'm CTO of Utopia Solutions, a QA and testing focused service provider. I've been involved personally in software quality and testing for over 25 years now, and spent a lot of time learning and helping organizations bring quality into their development organizations. You can always free to reach out to me, and I'll have this at the last slide as well, via email, Twitter, LinkedIn, and we will be recording this and posting it and sending it out to everyone, as well as sending a copy of the slides. All right, so let's get started. The agenda today, I want to start by talking a bit about common DevOps quality issues, just to set the tone, and then get into some key practices, some key quality practices that we can implement to address some of those issues. And then finally spend a little bit of time at the end to talk about some unique issues that legacy apps present from a DevOps quality perspective. So to get started, if we look at the 2019 DORA State of DevOps report and the clustering of performers between elite, high, medium, and low, we see that a significant percentage of low and medium performers, which is actually up it's at 62%, up from 52% in 2018. And the underlying story here is that while there are some fantastic successes in DevOps, and certainly we can see we've got 20% elite performers, and that's actually almost tripled since last year, according to the State of DevOps report. There's quite a few organizations that are either very early on in their journey or are struggling. And in either case, there's significant room for improvement, and a lot of that is related to quality practices. If we look at two of the four key DevOps metrics, mean change fail rate and mean time to restore service, that are typically most associated with quality practices, we see there's a huge discrepancy between elite and low performers. Now, these metrics are just symptoms. We can't simply say get better, improve them. We need to understand what practices are likely contributing to poor quality. So in order to do that, I think it's a good idea to look at some common DevOps quality issues and anti-patterns. And these are situations that we often see contributing to the inability to achieve the promises offered by DevOps. And in many situations, both throughput, so deployments per unit time, and product quality have worsened after beginning the transformation. So I want to talk about siloed testing activities, waterfall quality and testing practices, isolation of QA and test analysts, and finally check the box quality and testing. So let's start with siloed testing. As organizations transition from a model where dev, ops, and tests are siloed to DevOps, very often we see the test silo stain. And this might happen for a variety of reasons, but it's fairly impactful on DevOps. Very often there's a lot of time, money, and emotion invested in creating that center of excellence. And it's difficult to push against that inertia, even with the understanding that isolated test teams often face significant challenges in agile development models. And this situation results in a couple of common symptoms. First, even very often before the transition, right, the testing center of excellence was the be-all and end-all for many types of testing, certainly except maybe unit testing. But after that transition, the delivery teams have a hard time breaking from that model. So now we have this separate team, which is likely only capable of performing system-level regression testing, and maybe not doing that very well given they're separate from the delivery teams. But the delivery teams are leaving most of that testing up to them. So we result in a end of sprint catch-all, and it becomes very difficult, if not impossible, to deliver the fast feedback you need from your pipeline. So, and if you're waiting until the end of that sprint to begin your testing. And second, you're missing out on the benefits of having the QA and test focus within the delivery teams. These include identifying opportunities to build testability into both your application and your pipeline, as well as experience required to do effective exploratory testing. It's also worth mentioning that a common reaction to this very often when you start to feel the symptoms is to cut ties with that center of excellence and handle these activities within the existing delivery team, since in DevOps, quality is supposed to be everyone's responsibility. But independent of the skills and the experience to do that, you often get a tragedy of the commons situation where, because it's everyone's responsibility, it also becomes no one's responsibility. So next, I want to talk about waterfall processes and techniques that have seeped their way into the pipeline. It's closely related to the previous topic, but definitely worth mentioning. And seeing waterfall style processes in agile development teams is certainly nothing new or uncommon, unfortunately, but certainly also a cause for trouble in DevOps. We have unnecessarily heavy process that slow down the assessment of our build's deployability. Waterfall's end of cycle focus on testing delays critical feedback on the build. And finally, if you're using legacy quality and testing processes in general, that likely includes the approach to test automation as well. And that is likely going to result in a completely UI-based execution of test automation, and that further slows things down due to slow execution and reliability issues. But they all add up to one thing, and that's a testing bottleneck. Now, one way to tell if you've let these waterfall processes seep into your pipeline is if you're waiting for these resources to say it's okay to ship, right? Again, the reliance on the end of cycle, old model test center of excellence to put the final stamp of approval is not something that that does well in a DevOps environment. Next is isolation of the QA test analyst. So even in situations where we've broken free from that center of excellence model, we'll often see situations where the QA or test analysts are integrated, but they've become isolated. So even though they're technically part of the Scrum team, they've been relegated to their own QA testing corner within that team and working like they're still in their silo. You'll see the same symptoms as if they were sitting back in their center of excellence, waiting for requirements to be delivered, developing test cases, and then delivering the results, again, likely at the end of a cycle, all resulting again in that same bottleneck. Next is superficial QA and testing activities, and I like to call this check the box QA and testing. It's where your pipeline looks great in terms of everything you should be doing to build quality in and assess risk, but there's not much depth. So for an IT leader, your pipeline diagram looks great. You have the appropriate level of checks at every stage. You're monitoring system telemetry in both production and non-prod environments. You've got data from each stage and each activity being published up to a central dashboard. But the reality is very often there's some common smells when you have some superficial QA and testing in your pipeline. First, the build is frequently or always red, and due to flaky tests that result in false positives, and it gets to the point where they're effectively ignored. You have test coverage that's low or maybe even appears to be decreasing. That this results from difficult to maintain automated tests, and tests that are being removed, taken out of the pipeline because there's no time to fix them. Your dashboards start to be ignored because the data isn't reflecting reality. It's known to be suspect, and then the real information begins to be tracked in the shadows, and you don't have the visibility that you need. So we'll talk about how we can get beyond the surface level and be much more intentional about our QA testing practices a bit later. First, I want to move into talking about some practices, and the first one is to build a quality culture. I certainly believe that DevOps is a culture first. Yes, we're applying new tools and processes, but organizations that are high in elite performance have embraced the culture first attitude, and this has allowed them to effectively implement their processes and tools, but most importantly, continuously improve. And if we look at the three ways of DevOps that are discussed in the Phoenix Project and in more detail in the DevOps Handbook, the one that stands out from a quality perspective is the principle of continual learning and experimentation. It's very difficult, if not impossible, to progress on a DevOps journey in a positive way without going all in on continuous improvement. You'll almost always hear organizations talk about how they've carved off time to devote to continuous improvement, but very often that's only lip service. If you look closely, delivery is deadline driven, and that is just really resulting in doing waterfall one sprint at a time. So as an IT leader, you must make it safe for your teams to experiment and fail as fast as possible so they can continuously improve. This is going to allow you to implement and involve key quality and testing practices like continuous testing that's supported by effective test automation, continuous performance analysis and monitoring throughout your pipeline, not just in production. These practices, while certainly well worth the investment, are not easy to implement. You're not going to snap your fingers and make it happen. Organizations that have achieved this have started somewhere and then evolved and improved over time. And where they started matters less than the fact that they were given the time and the space to evaluate what's working and what isn't, and then incrementally improve over time. Moving on to another key practice, and that's to implement the foundational elements required for continuous integration and continuous delivery. Anyone doing or contemplating doing DevOps likely understands what continuous delivery is at a high level. According to Accelerate, the Accelerate book, the foundational elements of successful continuous delivery are comprehensive configuration, continuous integration, and continuous testing. I've also listed the key continuous delivery principles as well. But the important thing here is one to understand is it's one thing to implement the tools and processes associated with these foundational elements, but it's another thing to make them part of your culture. And if they're part of your culture, you understand the why they're important and why they're there and not just the how. So let's take a look at how CI and CD can impact quality, and then we'll talk about being intentional within our QA and testing activities to see what can be done about that. We know from the State of DevOps report, as well as the Accelerate book, that effective continuous delivery is a predictor of lower change failure rates, and that's a direct indicator of product quality. However, it helps to look at other metrics which are maybe more indirectly related to product quality, but just as important. Things like the amount of time spent on rework or the time spent on working on defects that are detected in production. According to Accelerate, the metric that is most tightly correlated with delivery performance was time spent on rework. They actually found that low performers spent an average of 27% of their time on rework, and that's certainly considerable. So great, it's all well and good if we have effective continuous delivery. We know that it will correlate with better product quality, but it's, again, not enough just to check the boxes on those foundational components, right? Yes, we have configuration management. Yes, we have continuous integration and so on. Very often checking the box means you have the tools or the infrastructure in place, but that alone doesn't guarantee effective continuous delivery. You need to implement those foundational components the right way. And we're going to talk about that now when we discuss being more intentional about QA and testing. So what do I mean by that, being intentional about QA and testing? I mean not just saying that you have the processes or tools, not just putting them in place, but really doing the hard work to make sure you understand the why and not just the how. And it's the hard work that breeds a culture of continuous improvement and eventually quality. Before we talk about some of the things we can do to be intentional, let's look at some of the consequences of not being intentional. And we can do that by revisiting some of those common smells that we talked about earlier. And probably the most common is automated tests consistently turning the build red. Let's assume for a minute that the tests aren't consistently failing because of bad code. In most cases, it's because you have unstable test environments or data or both. Possibly you've got too much UI testing, or maybe you're automating the wrong tests, not the high value tests, but the ones that were the easiest or most convenient. Most of these smells can be addressed by being very intentional about QA and testing. So we just talked about those three foundational components of continuous delivery. One of them was configuration management. And most of us have our application code under version control. However, data shows that managing the app code is not enough. According, again, to the Accelerate research, controlling the application configuration is much more highly correlated with the software delivery performance than the application code itself. Taking that a step further, right, again, controlling your build and deployment scripts is important. And if you employ infrastructure as code, managing that as well. This all goes a long way to providing a stable environment in which to execute those automated tests and starting to address one of the primary bad smells that contributes to you not being able to build quality into your pipeline. Moving on to continuous integration. According to the DevOps handbook, the two most important capabilities are a comprehensive and reliable set of automated tests and working in small batches on trunk versus long duration feature branches. So very often the mechanics of CI are there, but these two practices are missing. We'll talk about being intentional about test automation in a minute, but first, again, it's not enough to say your developers work in small batches or we're using trunk-based development. For developers that haven't done this before, they need to learn how to develop in small batches, and this likely requires training and organizational support. And further, it needs to be measured to make sure it's really happening, right? So what's your daily number of active branches? How many times are you merging to master per day? Those numbers will tell you if you're really doing trunk-based development and working in small batches required to be successful with continuous integration. Moving on to continuous testing. Again, saying we have these testing activities throughout our pipeline is not enough. There are a few things that we have to be very intentional about to make that happen. We talked about stable test environments coming from controlling the configuration a little bit better, and the positive impact that they can have on managing your application configuration. But the next is stable test data. We need to understand our data requirements associated with those tests and have a strategy to manage that so we can get it to a state where we have the test data available to run those automated tests on demand, at least at the frequency and the cadence required by your pipeline. And continually refining that strategy should be part of your continuous improvement efforts, because your data requirements are going to change over time. You're going to discover better ways, more efficient, more effective ways to manage that data. Finally, your tests have to provide accurate, fast, and actionable feedback, right? Otherwise, again, we just have a bunch of bottlenecks in our pipeline. We need to make sure that we're allowing the team to analyze what tests that are being automated, as well as how they're automating them, to make sure we're not only including just the high value tests, but that we're automating them in the most efficient way, right? Are they unit tests? Are we automating at the API level? Or is it something that really needs to be executed from the UI level? Again, part of that continuous improvement efforts should include an evaluation of those automated tests to make sure they're still the high value tests, they're still reliable. We're removing tests that have become obsolete, or removing or fixing unreliable tests. We talked about the anti-pattern of isolating QA or test analyst, and we found a great way to get the whole team involved to begin being intentional about QA and testing activities, and that's to use something called the test suite canvas. This particular form here was is modified from a concept originally developed by Katrina Clokey. She's got a great book called Testing in DevOps. But it's an exercise that the entire team participates in, or representatives in very large organizations, but it forces you to think very critically about the QA and testing activities in your pipeline. Not just the fact that they're there, but things like dependencies required to implement the activity, required environment and data situations. Certainly don't have time to go through the whole canvas today, but we'll include a link in a follow-up email that more fully describes how you can use it in your organization. So we hear a lot of amazing stories about DevOps transformations, but many of them are for greenfield applications where not only the processes and the tools, but also the applications were built from the ground up. The reality is, though, that many of us have legacy systems that we've maintained for many years and just don't have the ability to simply swap them out for more modern application architectures. So I wanted to spend a few minutes talking about legacy apps. Certainly been some great successes with organizations making phenomenal DevOps transformations that have included legacy apps, and I think we can learn from their journeys. But first, let's look at some of the common features of legacy apps and what typical outcomes look like for them in DevOps. We typically see the following characteristics associated with legacy apps. We have monolithic architectures. They reside likely in static, shared, stale test environments, likely have low unit test coverage, and especially for large systems, the application knowledge is very siloed, meaning that there's not a clear picture of how the entire system works internally, what those dependencies are in any one place. And that lack of system-wide knowledge resulting in uncertainty around the impact of changes. We just don't really know the extent of the impact that we're making to the application. In fact, it's not an uncommon system or symptom to see more time spent on figuring out where to make the change than actually making the change itself. We also see insufficient unit testing, and because there's not that sufficient upstream testing, we end up again with that catch-all test at the end of the cycle. And if we have automation, it's also likely inefficient because monolithic apps generally require UI-based test automation, and again, we're in a bottleneck situation due to that. And as we just discussed, these symptoms keep us from building a solid foundation for CI/CD and subsequently result in quality issues. In fact, it's not uncommon for organizations that had adequate quality see that quality decline as part of a DevOps transformation. And I believe anyway, this is because the time for the heroic efforts that were previously being used to maintain quality is now being drained by, in part at least, by the transformation itself. I think the good news is, though, this is a solvable problem. But as you might have guessed, it's not simple or easy. What we've seen be very effective, though, is to make a transformation first of the environment and have that be part of your DevOps transformation, along with the tools, processes, and of course, the application. So let's first talk about environments for legacy apps. It's not just the application that presents issues. Unfortunately, there's not a one-size-fits-all recipe for transforming your environment to something that's more friendly in a DevOps environment. But certainly, there's a high-level approach that we've seen prove very effective, and that is to treat the environment itself as a product, at least initially. We should have a long-term vision for the application that we're developing, and that drives us forward and helps us fuel that fire for continuous improvement. But however, often with legacy apps, we view our environments as a constraint to what we're trying to accomplish. But if we can flip the script a little bit and view our environments as a product, with the application delivery teams as the customer, we can build that same drive and continuous improvement into our environments and get some momentum moving in the right direction. This team likely has its own technical backlog focused on transforming the environment from a constraint to a value-added part of the process. As part of the transformation, a good place to start is to see if there are environments that we shouldn't be supporting. So we can do some value stream mapping to understand how each environment contributes to the work we're doing, contributes value to the work we're doing, and there may be some opportunity to consolidate or eliminate environments. Next, we can begin to look at the constraints and issues in those remaining environments and start to create backlog items for addressing them. This often involves, standardizing the configuration, addressing test data and a strategy for managing it. And of course, given that we're DevOps here, we're automating tasks related to the environments where possible. Once those environments have been sufficiently transformed to where it's a value add situation versus a constraint, we can start to transition to a more typical DevOps structure where the delivery teams begin to take ownership, and essentially the environment product team is working itself out of a job. Many teams, though, choose to keep that technical environment backlog to ensure they don't lose that momentum on continuous improvement in the environment area. So a little bit about the environment perspective. Let's take a look at some high-level things we can do at the application level. So, of course, we want to break the monolith of our legacy apps, right? Perhaps into something like microservices, and that's a fine approach, and certainly one that applies differently to almost every different application and environment. But the reality is that no matter what the application's ability is to be transformed, you're not going to do that overnight. And certainly that's a topic best left to another webinar. And if you want to look at a good high-level overview of how to approach breaking the monolith, I've included a link to a good article by Martin Fowler at the bottom of this slide. And again, we'll send the presentation out to all attendees here within a day or two. But regardless, while you're going through that process, you're still going to be making changes and enhancements to your legacy app. So let's talk about some things we can do to address some of those issues we talked about earlier. First, if we have siloed app knowledge, we need to create a dependency map to help everyone, not just the devs, but everyone understand the application at an architecture and a component dependency level. This is going to go a long way to understanding where and how changes need to be made, as well as better understanding the impact of those changes to drive decisions on the level of testing, regression testing, et cetera, that needs to be a part of those changes. We've also seen that creating a separate technical backlog for the app can help focus improvements that benefit the delivery teams and allow them to increase their throughput and quality. So again, not necessarily product features, but more technical features that make the application a little bit easier to work with and maintain going forward. So as we're adding features to existing code, we should be looking to refactor to make it as testable as possible. And certainly that's a lot easier said than done in an area that you probably should think about providing some training to your team if they don't have a lot of experience there. At a minimum, Michael Feather's book, Working Effectively with Legacy Code, has some great techniques and examples for refactoring legacy code to remove dependencies and improve its testability. Along with that, we should be looking to strategically increase our unit test coverage. I don't think anyone would recommend, myself included, going back and adding unit tests across an entire application. It's very costly, very time consuming, and the value isn't there. Part of the value of unit testing is its ability to improve design, and going back and applying unit tests to an application that's already been built, you lose that part of the value. But certainly adding unit tests to code that is being touched, so anything new, enhanced, or that's being fixed. Also adding tests to areas that are error prone or high criticality or have a high change frequency are other areas that you might want to consider beefing up unit testing. And one thing we found is that while most developers certainly understand unit testing and do it to some degree, there can be a great deal of improvement with a little bit of training and or coaching. And again, especially in situations where we have legacy apps, which looking at the legacy code may not be as testable as it could be. So they'll need to learn some techniques again for refactoring that code to break some dependencies and make it more testable. All right. Before we wrap up, I want to enforce some key concepts that we just talked about. I think first and foremost, continuous improvement has to be part of it. Again, we often see part of an organizational charter talking about time and effort devoted to continuous improvement, percentage of effort per sprint, et cetera. But very often that isn't happening. It's deadline driven. If you want to improve the quality in your pipeline, you've got to devote time to continuous improvement. Be aware of those DevOps quality symptoms and smells. Flaky, unreliable tests that turn the bill red, data that is being ignored, data being tracked in the shadows. Those types of things are key indicators that there's some issues that need to be looked into. And a good way to start addressing those is be intentional about those QA and testing activities. Again, go beyond the check the box testing, understand why you're testing, understand what the constraints, dependencies need to be in place for those activities to be successful. And again, I'll say it again, continuous improvement. You're not going to be able to affect much change without that being part of your culture. Finally, if any other questions come up or you haven't just want to discuss any topics or need a sounding board, you can always reach out to me at any of those methods there. So please feel free to do that. Again, we recorded the webinar. We'll send you a link to the recording as well as the slides. And just I will get back to any questions that were submitted. I see there were a good handful within a day. I'll do that directly via email. And want to thank you again for joining and spending part of the day with us. Thank you.